So let's talk about the final two operations involving rational expressions, how to add and subtract, which is basically the same as adding and subtracting numerical fractions, except we're dealing with variables in the numerator and or denominators. So remember when we add or subtract numerical fractions, denominators have to be in order to add or subtract, denominators have to be the same, right? So we may have to convert one or the other, or both, before we can add them, before we can subtract them. So we find the lowest common denominator. That's this. So when we did for numbers, numerical fractions, that was the smallest number that all the little denominators went into. So if you were adding, say, 3 fractions, and the denominators were 4, 6, and 8, the lowest common denominator would be 24 because that's the smallest number that 4, 6, and 8 divide evenly into. But what if we introduce variables? Okay. Well, you kind of have to look at it logically. And another thing, you can always find a common denominator by multiplying the denominators. Okay, so for example, the lowest common denominator, if you had 2 and 3, is 6, or 2 times 3. But that doesn't work all the time. Like if the lowest common denominator of 2 and 4 is 4, but 2 times 4 is 8. 8 is a common denominator, but it's not the lowest. Okay, so when we've got variables, let's say we're asked to find the lowest common denominator if we had 2 fractions and those were the denominators. Well, first of all, do the numbers. 2 and 3. What's the smallest number 2 and 3 go into? 6. Would you all agree that in order for this to go into whatever my LCD is, I need a PQ here? Right? I need a PQ so that this denominator goes into it, because this has a PQ. But if I look at the other denominator, not only, so I've got this covered, 6 works, I've already got a P in there, but this is new, isn't it? So to find the lowest common denominator, it would be 6PQR. Because I do the numbers, and then I got to make sure all the variables are represented. If you've got exponents, okay? X squared y is one of your denominators, xy squared is another. What would be the lowest common denominator? Just x and y? If it was just x, y, would this go into it? No, because there's not enough x's. So what do I need for this to go into it? I need an x squared. So this goes into it, but now this doesn't go into it. What do I need so that this also goes into it? A y squared. Okay. If you've got binomials in the denominator, it's actually really easy to find the LCD. Remember what I said, you can find a common denominator just by multiplying? You will always find the LCD with binomials by just showing them being multiplied. That's it. Because this goes into it, because there's an x plus 2 in here, and this goes into it, oops, sorry. Because there's an x minus 3 in there. So now that we've covered common denominators, just remember when we add and subtract, the denominators have to be the same for addition or subtraction, And then it's basically saying we add the denominators together and put it over the LCD, right? We subtract the denominators, put it over the LCD. Oh, and by the way, again, don't multiply this through. Leave it. Don't multiply it through. You don't, because in order to find LCDs of these kind of expressions, they have to be in factored form. Once you multiply through, it's no longer in factored form. So if you multiply these through, to find an LCD, you'd have to factor it back anyway. So you're just wasting a lot of time. Okay, best way, let's tackle examples. And whenever you see more than one term in a fraction, remind yourself to put parentheses around it because those have to stay together. So here's how we're going to do it. And when I reviewed fractions way back in grade 9, I should have showed you the way that I prefer to do fractions. Like, you don't have to write this down. If I do this, like most of you will do this. And then you get 11/12. Okay? I prefer this method. Make the single denominator right away. And then this gets multiplied by 3, so this gets multiplied by 3. Plus, this gets multiplied by 4, which means this must be multiplied by 4. 8. I have to change that. Okay? Because doing it this way actually makes more sense when we do these. Okay. So what's the lowest common denominator? 12. So I'm going to make a single fraction right away. What must I multiply the top and bottom by in the first fraction to get this? 3. So just remind yourself this gets multiplied by 3 to make 9x. Minus, this one must be multiplied by 2 to get 14x. Now I can actually simplify the top. Negative 5x over 12. Look at the numbers and see if they can be reduced. They cannot. So we're done. For the second one, this is probably one of the easiest questions you'll see, but students always make it the most complicated. What do you notice about the denominators? They're the same. So the lowest common denominator is just this. And I don't have to change the numerators. It's just 8 plus 3 over x minus 4, which is 11 over x minus 4. Do you need the parentheses here if there's only one set? No. But I always like to write them just to remind myself that those two have to stay together, especially if you're able to reduce them. Here's where parentheses really help you, because if you don't put the parentheses, chances are you're going to make a certain type of mistake. What's the lowest common denominator? N, which means I don't have to change either one. So it's m minus, and remember, this m plus 1 has to stay together. What holds it together? Parentheses. Because notice when you simplify, the signs are going to change. Because you get m minus 1. If you didn't put the parentheses, you would think it was plus 1. That is a common mistake. What does the top simplify to? -1 over n. Oh, and by the way, the instruction said you didn't have to state non-permissible values. I usually do that for adding and subtracting. I don't make you state them. You're already doing plenty enough work in these questions. Usually for multiplying and dividing, I get you to state. What's the lowest common denominator? X squared. I need an x squared in order for both of them to go in. Well, the second one doesn't change. But I must multiply the first numerator by x. Remember, when you have more than one term in a numerator and denominator, you have to think of it as together. Why? Because, and a lot of you guys still do this, and I want to review this from the last test with radicals, because you guys are making the same mistakes over and over again. You're not correcting them. You think you can cancel an x from there. You can't. You can only cancel x squared if there is an x squared up here. You can only cancel x if the whole thing 4x plus 6 appears down here. Otherwise, you can't. You can't pull something out of while it's being held with something else. Anyway, we can't add these together, so that's as far as we can go. Now we start to get a little more complicated. Again, remind yourself. What is the lowest common denominator? Notice I'm writing a bigger fraction box. X plus 3 times x minus 2. What must I multiply this first one by? So what's in here that's not in this one? X minus 2. That's what that has to get multiplied by. Minus what's in here that's not in this one? X plus 3, which is what I have to multiply the 5 by. And I can do some simplifying to the top. I can remove the parentheses. What do I get when I remove the parentheses? 4x minus 8 minus 5x minus 15 over x plus 3 times x minus 2. And I can go a little bit further. 4x minus 5x is negative x. Negative 8, that gives us negative 23 over x plus 3 times x minus 2. That's as far as I can go, and there's nothing to reduce because there's no identical terms, binomials in the numerator and denominator. It's easy when it's just binomials, right? Can I make these into binomials? What's that called? What is that process called? Factoring. So factor these. So this is the same as before. I'm just going to factor them here before I write a new step. X plus
6. Wait.
I'm waiting. It's not 6 and 1.
It's not 6 and 1.
It's 3 and 2. X plus 3, x plus 2. This one,
Minus 2 plus 1.
Nope.
Minus 1
Minus 1 plus 2. Because notice, what's the lowest common denominator? I have to represent all of them. I need an x plus 3. Sorry?
plus 1.
Why aren't you going to this one?
And 2 plus
Like, just go this way. It needs an x plus 3. It needs an x plus 2. It needs an x minus 1. But does it need another x plus 2? No. So this time we have 3 binomials as the LCD. So we play a little Sesame Street to convert. One of these things does not look like the other. What's in here that's missing here? That's what I have to multiply this one by. What's in here that's not in here? X plus 3. So that means I've got to go 2 times x minus 1 plus 3 times x plus 3. So I've got a couple of steps to do up top. Remove parentheses and I get 2x minus 2 plus 3x plus 9 over these 3 binomials. Simplify the top to get 5x plus 7 over those 3 binomials. Nothing to cancel, nothing identical to cancel. Okay. I'm going to do a couple more because I'm going to do those. We're not going to worry about compound fractions, complex fractions. Okay. Let's do this one together and then I'm going to get you to try that one. So I'm just going to remind myself. I've got 3 terms in one of them, which means it needs to be fat. What does this factor do? Y minus 1, y plus 2. What's my LCD? I need a y minus 1. Already got that. I need a y plus 2. Well, don't have to worry about changing the second one, but I do have to multiply the first one by y plus 2. And notice, that's going to be 4 multiplications. So we've got a fair amount of work to do up top. So when I do my 4 multiplications, I get y squared plus y plus 2y plus 2, and then subtracting the second set of parentheses gives me minus y plus 1. Notice those can go. Plus y minus y. Don't have to worry about those. I gotta write in my denominator, y minus 1, y plus 2. And then what do I get? Y squared plus 2y plus 3 over that. This one almost looks like it could be factored. Yeah. It's close. No, not quite. Because I need this to be minus 3 in order to get this thing. So I can't factor it. But that's something that you should look for. Because if we were able to factor it and we found two identicals top and bottom, we can reduce it. Okay, you guys try the next one. Go as far as you can. If you're not sure, please. You should get x minus 2 times x minus 3, or x minus 3 times x minus 2. And for this one, you should get x minus 4 times x minus 3. Which means that the lowest common denominator is x minus 2 times x minus 3 times x minus 4. Don't need the second x minus 3. Oh, sorry. And myself. First one has to get first numerator has to get multiplied by x minus 4. So I've got to do x minus 4 times x plus 3. Plus, second one has to get multiplied by x minus 2, yeah. So that's going to give me up top x squared plus 3x minus 4x minus 12 when I do my 4 multiplications. That's 6x minus 12. Over this LCD. If I simplify it, I get x squared, and then I've got 3x minus 4x plus 6x is 5x. Minus 24. Do I stop? Or can that top be factored?
8 and 3.
8 and 3. So this can actually go to x plus 8 times x minus 3, which is important because that means that there is something to reduce. So I was able to factor the top this time, and it gave me two identical binomials that I could cancel out. So I am left with x plus 8. If there's a single binomial up top, you don't need the parentheses, but I'm going to keep them in. And now there's only two binomials left. Okay? Look a little complicated, but if you know your algebra, and if you know your factoring, okay, you'll be fine.